is your review for Module 1, so we have tests next week. And I decided that I was not completely crazy with the review in the book because it is really running on the old Wiley material, not the new My Open Math material. So I created a new review for the problem sets in there that are closer. Sign in and pick up handout if you have it. Okay. If you want something that's close to what the problems are on the test, these are closer. You know what I'm saying? It's not that it's not a good review that's in the book. It's great. It still does help you to work the same types of problems. It's just I think you also need this in addition. Do you understand what I'm saying? The other thing that you're going to need, besides what I'm going to tell you today that is on that new handout, is you need to go back through chapter 1 and 2 and make sure you understand the terminology. The terminology is really important, especially on this first test. It is 50 questions. It is a lot of vocabulary. So do you understand the vocabulary, how to use it, how to interpret it? That's really important here, okay? And it's more than just memorizing the definition. It's do you understand it? How would it be used? So that's going to be the key to studying for this test. So I want to take this one and use this as our test review, if I may, today. Okay? So you can put that at the top of this page. This is the test 1 review. And I'm going to start out by giving you a data set, which is those items right there. And I'm going to ask you to give me the percentile rank. And then I'm going to ask you to do something else. I'm going to ask you to give me the value of the 56th percentile. Now, you do have on the test, you will have this formula sheet, okay? So chapters 1 and 2 and all the formulas that we've used are right here. So what you're going to be doing, guys, is go in here and saying, okay, percentile and percentile rank formulas are right there. Do you see them? So those are the formulas that I'm going to be using to do this calculations, and it's going to be important that you note that these data sets have to be ranked, right? So what do I mean when I say ranked data? In order, smallest to largest, right? Is this one in order, smallest to largest? Okay, hint, on your test, your data sets are not going to be ranked. You're going to have to do that. So however you choose to do it, if you choose to take your time and do it, but if you are working with a graphing calculator, can I just see your hands if you plan to be using a graphing calculator on the test? Okay, but not really. So anybody who's not, let me see, not planning to? That one, okay. Okay, so let's look at it if you are using it, because if not, what you're going to be doing is ordering it yourself. You know what I'm saying? So you're going to have to put it in order yourself. Let's do this. Let's go to Stat, and let's go to Edit, and let's just pick a list and clear it, and put this data in it. So I got 40, 42, 41, 30, 18, 29, 36, 37, 38, and 38. Now, you can plan on your data sets if you're doing this by hand without the calculator, you can plan on your data sets not being any bigger than this. So how you would get that ranked, you would just have to write it down in order and make sure you get it right. Now, I've put it all in list 1, and I kind of go through and check it and make sure I did it right. I think I got it right. And then I would go Stat, and you see where it says Sort A? I'm going to choose that one. And I'm going to tell it I want it to sort list 1, close parentheses, and it does it. It sorts it. Does everybody get that? Do you need to see it again? So you're under Stat, and it'll have a sort option. Hopefully your calculator works about the same way it should. Close, most of them work like that. Now, I'm going to go back to that list and look at it, edit the list, and then I can write it down in the order, the ranking that it gave me, because that's really what I needed that for, okay? So I'm going to write these down underneath. I'm going to say the first one, see if I can get it all up here. The first one is 18, second one is 29, and then I have 30, 36, 37, 38, 38, 40, 41, and 42. And this is a really important mathematical function here. Draw a line through the old data set so you don't accidentally use it, okay? Trust me, that is important. It really is. All right, so now I want the percentile rank of 38. So how do I get the percentile rank? Let's look at that formula real quick. The percentile rank says I have to of A, so the value that I want is A. What's A in this one? Well, A is equal to 38. Percentile rank of 38. So that's my A value. And then it says I need X's and Y's, where X is the number of values less than A, and Y is the frequency of A. So X is the number of values less than 38. Well, let's count them. 1, 2, 3, 4, 5 are less than 38. And Y is the frequency of 38. How many 38s do I have? Well, there's 2 of them. You can't do this if this thing is not ranked. You understand why? So now I've got that. So I'm going to say the percentile rank of 38 is equal to, and the formula tells me, and you can see your formula sheet, it's X, that would be 5, plus 0.5 times Y, which is 2, and all of that is divided by the number of items, the values in the data set. How many are in my data set? How many was it? 10, thank you. There's 10 of them, that's in, right? And then I'm going to multiply that times 100% when I finish with it. Well, let's just do that first. So 5 times this is going to give me, what did I get? 0.6? Did anybody do the math? I can't ever get out of something when I'm in it. And I would love it if one of you would show me how. Okay, so I've got 5 plus 0.5 times 2. That's as much as I can do if you're trying to do it that way. And then you're going to say divided by 10, right? And then you're going to say times 100%. And you're going to get 60%. The percentile rank of 38 is 60%. What is that telling you? It's telling you that 60% of the data falls at or below 38. You got it? Be sure you can interpret it. It's more than just knowing how to calculate it. You have to know what it means. Look at my data set. Does it look kind of right? 60% is right at 38 or below it? I'd say that's a pretty good estimate if we were just eyeballing it, right? Okay? All right, so now what about this one? What about if they ask us not the percentile rank, but what if they ask us, what's the 56th percentile? Well, that's a different formula entirely. So don't mess yourself up. What's the kth percentile is right here. The 56th percentile has a different formula. It says you want to find the item for the 56th percentile, you use this formula, right? So I'm going to say the 56th percentile, the item that is the 56th percentile is equal to K, and write it down for yourself. K is equal to 56, okay? So it's equal to 56. Your formula says divided by 100, multiplied times n plus 1. Well, that's 10 plus 1, isn't it? It's not a hard formula. You guys have had lots worse in your lives, haven't you? This is not bad. So I can say, okay, that's 56 times 11 divided by 100, right? This is 11. Or I can say 56 divided by 100 times 11. As long as I'm doing all multiplication and division, order of operations will not get me in trouble. If I try to do this addition in there without putting it in parentheses, I will be in trouble, okay? So I would say 56, well, however you want to do it, times 11. And I get 6.16. I'm not done, okay? Because it's saying what is the value of the 56th percentile? Well, the term, and that's what this I stands for, it's the term in the data set. The term in the data set that represents the 56th percentile is the 6.16th term. Well, there's no way to find that one. It's between two, isn't it? It's between the 5th term and the 6th term and the 7th term. Yeah, I knew that was wrong when I wrote it. Okay? So what is The sixth term of my data set. Well, 1, 2, 3, 4, 5, 6. It's 38. What's the seventh? 1, 2, 3, 4, 5, 6, 7. Well, it just happens to be 38. So what do? Well, I average those. I say 38 plus 38 divided by 2. Didn't even have to do it, did I? What is it?
Mrs. Milner?
Yeah.
I'm going to leave, okay? I have an emergency.
Okay. Okay, so I got 38 plus 38 divided by 2 is going to give me 38, yeah?
I have a question. When you get in between the 6th and the 7th, how do you get that?
When I get in between the 6th and the 7th?
Yeah.
Okay, so you say it's got 6.16. I go down to a whole number, which would be 6.
Okay.
I go up to a whole number, which would be 7.
Okay.
Does that make sense?
Yeah.
I'm in between 6 and 7.
Okay.
Yes.
Is your mic on?
Probably not. Oh, yeah, it is. Hey, guys, I got bad news. Echo 360 broke again. I meant to tell you that at first of class. Did you see the guys out in the hallway with it? Okay, they're working on it. And I don't know that it's fixed for this class, so I will probably be going home and recording this for you because this is a brand new lecture that I've never done before, so I don't have it recorded. So I'm really sorry about today. They have promised me that they are equally sorry and they are working as fast as they can to get Echo back and running for us. But today is probably not going to be recorded, okay? And you have a test on, when is your test? Wednesday, so it'll be back before your next class period. So worst case scenario, I will record this one and post it for you, and I'll send you an email when I do, okay? Are you set okay? Okay. So best, it'll have to do, right? All right, so does that make sense? I go to the 6th, I go to the 7th because 6.16 is right between those two. Are we okay? Okay. All right, so there's your percentile. Now, I have a new problem set. So those are percentiles, and those are really the two questions that can be asked to you about calculating percentiles. Calculate the percentile or calculate the percentile rank of a data item. You understand the difference in those two? This one, it gives you the data item. This one, it asks you to find the data item, right? The value of the data item. Okay, so here's the next problem. I gave you a little table. It's favorite animals, and these people were polled, and they were asked, did they like dogs or cats better, or neither? I made the data up, so don't get offended if you are a cat person, okay? Anyway, what I'm asking is, do you know the difference? Would you know how, in this data, to tell me what the percentage, if I asked a question about the percentage of dog people in this table, would you know how to calculate that? Tell me how. I put you on the spot. Okay, so you're going to sum them. So the sum of this is important, and he's right. How many is that? Okay, we got 30 of them. Which I did wrong when I did the key. So it's really funny. Okay, so anyway. So we got the sum of these. And now if I want the percentage of dog people, how am I going to do it?
We divide the number of dog people, which is 12, by the total number, the sum of F, which,
30,
yeah,
right?
30,
Yeah, the sum of n, right? The sum of the frequencies are n, right? Whatever you want to call it. This is n. It's also the sum of the frequencies, isn't it? Sample size or sum of frequencies, whatever they call it there. So yeah, you're going to take the dog people and you're going to divide it by all the people that were surveyed. And we got to do these numbers again because I did them wrong last night. I was in a hurry. So 12 divided by, plus it's really bad to do math while you're watching a movie. Have you noticed that? You make mistakes that way. So I get 0.4. Is that the percentage? What do you do next? Yeah, we're going to say times 100%, right? Or we're going to translate that into a percentage and we get 40%. Let me fix something real quick so that I don't have this issue again. Okay, good? Are we good? Okay, so now if I ask you the relative frequency of a group or a category or of a, do you know how to get the relative frequency? Yeah. Yeah, this is the relative frequency, isn't it? This is the only difference in relative frequency and the percentage is I took the percentage and multiplied it times 100% to represent it. There's no difference in these two questions, is there? Except for this one, I asked you to represent it as a percent. That's the only difference. So relative frequency of these neither people, how many of them are there? 8, divided by the total 30. I don't know that number either because once again, I get, let's just go to 2 decimal places, shall we? Round to 2. Pay attention on your test. It'll tell you how many to round to. So I got 0.27. Okay? All right, so that's a couple of questions that you could be asked. Let's look at the next group that we might. So if I tell you, now you're going to get a lot more detail than what I'm giving you, but I have picked the information out of a problem, and I've found that this problem has 150 people in the sample, okay? So I said, okay, n is equal to 150, and they gave me the mean. The mean is 61, and they gave me the standard deviation, which is 5. Now this was a long word problem, so you got to be able to find those things, right? But in this problem, that's what I wrote down. And then they said, what percentage is between 2 numbers? Now listen, I've got 2 choices when they ask me what percent is between certain numbers. I can use empirical rule or I can use Chebyshev's, right? I've got those 2 possibilities. Another important thing to note, empirical rule can only be used if you have a normal data set. Now, standard normal data set, equally distributed on both sides, bell-shaped curve, all those mean the same thing, right? I cannot use the empirical rule if my data set is skewed at all. That's when I have to use Chebyshev. I have no choice. But I'm not telling you this because I just want you to calculate it both ways and see the difference. I just want you to, you'll know whether to use the empirical rule or Chebyshev's because the problem will tell you using Chebyshev's or using the empirical rule, right? So I just wanted you to have a little practice. If I ask you what percent are between these 2 numbers, well, you got to think about it like this. I've got my number line, and I've got my mean in the middle. And I've got the 2 numbers that they told me they're interested in. I'll put them on each side. Now, my data set's going to kind of look like this, okay? I don't know if it's skewed or not, so I just draw it like that. I know the center of the thing is the mean. Pretend that's in the center, okay? And I know that this line and this line are the points of interest. So it wants to know what percentage are between these 2 numbers. Well, I have to know for both Chebyshev and for the empirical rule, what I have to know is how many standard deviations this represents. How many standard deviations from here to here, and how many standard deviations from here to here. 1 standard deviation is 5. This is a distance of 10, and it has to be the same distance for both of them, right? So if 1 standard deviation is 5, how many standard deviations is this? This is 2 standard deviations, and this is 2 standard deviations. So what am I saying? It is, for this one, it is within 2 standard deviations of the mean, right? Isn't this saying what percentage are within 2 standard deviations of mean? Within means plus or minus 2, doesn't it? This is 2 standard deviations, that's 2. Are you all following me? I'm saying it over and over because I'm getting blank looks, but you get it, right? Within 2 standard deviations of mean. So go look up the empirical rule. It's on your formula sheet. The empirical rule says for a normal, and it tells you bell-shaped distribution, 68% are within the mean and 1 standard deviation, mean minus 1, mean plus 1. Hang on, I'll get to it in a second, okay? And then 95 are between the mean minus 2 and the mean plus 2, and 99.7 are mean minus 3 and mean plus 3. In other words, 68 are within 1 standard deviation, 95 are within 2 standard deviations, and 99.7 are within 3 according to the empirical rule. It tells you no calculations involved. Question? I found out how many data items was between 51 and 61. I subtracted. So there's 10 between those 2. You got that? And then 1 standard deviation is 5. So 10 divided by 5 gives me 2. Right? Anybody else? You good? I just need to know how many standard deviations. Okay, so 2 standard deviations, what did they tell me again? 95%, right? So what percent are between it? According to the empirical rule, 95%. All right? That's the empirical rule. Okay, what if it's Chebyshev? What if they had asked us the same question, but it was Chebyshev, not the empirical rule? Well, for Chebyshev, you got to do something different. You still have to find out how many standard deviations you're talking about, right? All of this stuff still goes, we do it the same no matter what. We're dealing with 2 standard deviations still, but this time for Chebyshev's, we plug it into this formula, 1 minus 1 over k squared, where k is equal to the number of standard deviations, right? So for Chebyshev, I'm going to say 1 minus 1 over k squared, and I'm going to say k is equal to 2, number of standard deviations, right? And then I'm going to say, well, that's 1 minus 1/4. And guys, how many fourths, if I take a whole number and I subtract 1/4, how many fourths do I have left? 3/4. Now you can use your calculator if you want to, but tell me what percentage that is. Think quarters, right? According to Chebyshev, it's 75% falls within 2 standard deviations. Which one of these would be correct? Well, empirical rule, if it's a standard normal data set, we would use it. It would be closer to accurate. We can get really, really accurate if I have a standard normal bell-shaped curve. That's why the empirical rule can be as detailed as it is. But Chebyshev is saying, listen, you give me any data set and I will say at least 75%, at least 75% fall within 2 standard deviations. I guarantee it. But he won't guarantee any higher than that. Like the empirical rule guarantees the 95, not Chebyshev, because you might have a skewed data set. And it can't go any higher because the data might be shifted. It doesn't really know. Before Chebyshev did this theorem, though, we didn't have anything to go by except for the empirical rule. I sound like I was alive back in the 1800s, don't I? But truly, this is what it was. Truly, this is what it was until he came up with all of his calculations. This is better than nothing. Before this, we couldn't estimate a data set that was not standard normal, okay? But now we can. Do you understand what I'm trying to tell you? Okay, so if you're asked what percent are between 2 numbers, your first thought is, how many standard deviations are we talking about, okay? I don't care if it's Chebyshev or empirical rule, your first thought should be, how many standard deviations is that? Now, the standard deviations always have to be from the mean to one of the numbers. It's going to be identical on both sides. So you can calculate just one side of this and not worry about it. If it was not identical, this wouldn't work. The researcher would have had to change his numbers to make it identical, okay? Are you good with that? All right, let's look at another question. Let's say we're asked how many items, how many data items, not what percentage. Okay? How many data items are between 46 and 76 this time? I gave different numbers, didn't I? Okay, so that's a totally different question. So what I've got to do, I've still got to do basically the same sort of thing here. I've still got to come up with, how many standard deviations am I talking about? Well, let's draw another one, okay? Because these are different numbers. I'm going to draw my curve right here. I'm going to draw my number line. I'm going to say the middle of it is 61, right? This time I'm going between 46 and 76. I'm going to just put the curve up here so I can tell what I'm doing. And what I need to know, okay, pretend it's in the middle, all right? I'm getting really bad at drawing these things. So what I really need to know is how many data items, how many points am I talking about here between 46 and 61? Well, I've got to go 61 minus 46, right? I don't know why I didn't. What is it? I didn't finish my notes last night. Man, I can't remember what movie I was watching, but it was really distracting me. 15? So I'm going to assume I got it right because I made up these numbers. Let's just check me. Okay, at least I did that right. So 15, how many standard deviations is that? Does everybody understand? One standard deviation is 5, 15 is 3 standard deviations. So now it's saying, according to the empirical rule, how many data items would be falling between 46 and 76, right? Within 3 standard deviations, yeah. Say that again?
Is one standard deviation always equal to 5?
No, no, no. Every data set is different, but this we're still running on this same data set. Okay? I didn't give you a new data set. I'm still using the same one. N is 150, the mean is 61, and the standard deviation is 5. So yeah, you'd have to look for, standard deviations are different for every data set. Good question. All right, so I found it was 3. What does the empirical rule tell me? What percent? Because that's all it tells me. Empirical rule tells me what percentage falls within 3 standard deviations. What is it? Yeah. Okay, so I got 99.7% of what? Yeah, of the sample size. That's how many of that sample fell in that area, okay? So I'm going to say 0.997 times 150, right? I don't know what I was thinking last night because I did it with 2 for some reason. I got 149.55. So we would say we'd probably go to 150, wouldn't we? Because we got to have how many? Now, does that make you understand? We're asking how many data items. If we were saying at least, we would say at least 149. You'll have no problem figuring out which one it is, okay? At least 149. It rounds to 150, but at least 149 covers us. Let's do it with Chebyshev now. Can you do the same thing with Chebyshev? What is K? All right, same formula. This time K is 3. Find the percentage and multiply it times the number of items in your data set to find out how many of them, okay? Go to 2 decimal places, you'll be okay with that. You could do 3. We did 3 before, didn't we? So 889. And then I'm going to say 0.889 times 150. And this time I come up with 133.35, so I say at least 133, right? And I believe that's the way it's all worded. All right, do you understand the difference in that? Asking what percentage is between and asking how many actual members of the sample, how many actual data points fell between it. Okay? If they ask you the number of data points, you've got to multiply the percent that you find times the number that are in the sample. Are we good? Okay? You ready for the next page? All right, let's look at this table. Now this one is grouped data, isn't it? So if you're running calculations on grouped data, keep in mind that the formulas that you're using have a midpoint and a frequency. Look, variance for grouped data, standard deviation for grouped data. Do you see them down here? Mean, where's the mean for grouped data? Right here. They have a midpoint and a frequency. No longer can we sum the values for x because we don't know the individual x values anymore. They got lost when we grouped them. Look at this group. There are 10 in this age group that fell between the ages of 40 and 49. Well, how many of these 10 were age 45? How many were age 42? We don't have a clue, do we? So how would we have the x values to add up? Well, we don't have the x values anymore. We lost them when we put them in groups, didn't we? So the only way you can do grouped data is you have to say, okay, the middle of this group times the frequency. That's going to be close, isn't it? That's what I got to do. So I'm going to come up with the midpoint of each group. And the midpoint of each group is going to be take the lower limit, add the upper limit, divide by 2. That's how we do it, isn't it? So I say 40 plus 49, and I go divided by 2, and I got 44.5. By the way, what is the width of my groups? The widths are going to be the same for all of the groups. So what's the width for this table? 10. How'd you get it? Putting you on the spot. How'd you get it? Who said it? I don't know who said it. Tell me. Okay, well, one of you tell me how do you get it? How do I get the width of the group?
We count each individual number.
Okay.
Yeah, that's how I do it.
So you said 40, 41, 42, 43, 44, 45, 46. What about I just take limits and subtract? I take these two lower limits and I say 50 minus 40, it gives me, or I take these two upper limits, I say 59 minus 40, it gives me the width. It doesn't matter which two I pick, right? 70 minus 60, 89 minus, you see what I'm saying? It's always going to give you the width of the group. It's always going to be the same number. If it's not, the table's wrong. Okay? So what's the width of the groups? 10. You're right about that. But this is going to be, it's going to increase, this midpoint, they're going to increase in increments of 10. If the first midpoint's 44.5, I can add 10 to it to get the next one. I can keep adding 10, and I don't have to keep adding the two limits together and dividing by 2. I think I did that right. Sometimes I can't do that and talk. Does that look like your midpoints?
Yeah.
So those are the midpoints of my group. Now, what if I ask you some questions about them? You could tell me, what's the midpoint of class 2? Well, you can go up here and say, well, this is class 1, 2, 3, 4, and 5. There are 5 classes or 5 groups. What's the midpoint of class 2, guys? Okay, 54.5. What's the upper limit of class 4? Okay, upper limit, right? Upper limits. What are these? Lower limits. Okay, good. So what's the boundary between class 4 and 5? That's a tough one, isn't it?
79.5.
Yeah. Here's class 4, here's class 5. We're saying what's halfway between these two numbers, right? 79 and 80. You would go 79.5. Wouldn't you? Halfway between 4 and 5. Okay? Practice. What's the boundary between class 1 and 2? Look at it. 49.5. Okay, what's the lower limit of class 1? 40. Good. What's the upper limit of class 3? Upper limit, not the boundary. What's the upper limit? 69. Just plain old 69, right? Boundaries are halfway between the classes. Limits are the exact number, isn't it? Okay? Okay, that's good. All right, so what's n? Now it's the sample size. How am I going to, do you see n anywhere on this page?
But we have to add up our frequency of all of our.
It is. The sum of all frequencies is equal to n, right? So somebody add those up for me. Tell me what you get for n, because I don't trust what I got last night. 44?
Yeah.
I did that right. Okay, so I'm just going to say that's equal to n, isn't it? Okay, what's the mean of this data? Not as easy a question as it may seem, right? So what's the formula for the mean of grouped data? sum of midpoint times frequency divided by the sum of all frequencies, n, right? That's my formula. You can find it in your formula sheet. Make sure you can. So what do I have to do? Well, I have to have m times f, don't I? M times f. And then I have to add them together, and then I have to divide by 44, right? So I could come out here, and by the way, this is sample data. I'm telling you that for another calculation. I could come out here and I could put MF down, right? And I would be saying 10 times 44.5, well, that's going to give me 445. And I could say 14 times 54.5, 763. And 13 times 64.5. And then I say 5 times 74.5. I'm making it too easy on you. I'm hoping I did the math right. 2 times 64.5. All right, anybody check me on this? Nobody's checking? Sum of midpoint times frequency. I got 2588. So I would say this is going to be 2588 divided by 44. That's the mean. Why do we have to do this? Why didn't we just add up the data items and divide by the total number of data items? Because it's grouped. Grouped data, you can't. You lost the individual details, okay? So, what'd you get for the mean, somebody? You're waiting for me to tell you, aren't you? 58.812, something like that. I went to 8182. I think I went to 4 decimal places. You'll know how many to go to. Okay, what if you have a calculator and you want to do this in your calculator and you don't trust your math, right? Let's go to our stat list. Let's edit a couple of lists. I'm going to clear list 1 and I'm going to clear list 2. And in list 1, I'm going to put the midpoints, okay? So I'm going to say 44.5, 54.5, 64.5, 74.5, and 84.5. Okay? And check it. Good? And I'm going to go right over here to these, and I'm going to say the frequencies, 10, 14, 13, 5, and 2. Okay? Midpoints are in list 1. Frequencies are in list 2. For me, it's a good idea to write that down. I'm always trying to run some sort of thing on list 3 when I actually put it in list 6, and it can't figure out why it doesn't turn out. So it's a good idea to write down where you put it. And then you go stat, and you're going to go over to calc, and we're going to do one variable statistics. Now what I want, this time I have to have a frequency list. I say my midpoints are in this one, my frequencies are in this one. If you don't have this little menu thing, then it's going to come up with one variable statistics, paren, and you're going to say L1, comma, L2, close paren, okay? If you're in an 83 or something like that. And this one's going to do it for me, and it's going to run the statistics. Now let's see how close we got. What was that mean that we calculated? That looks right, doesn't it? It also tells me the next thing that I need to know, which is the standard deviation of the data set. But which one of these do I use? The sample or the population? Yeah, I told you, didn't I, that it was sample data. That's the only reason you know. So I'm going to say this standard deviation is 11 point, and I'll go to 4 decimal places. And then how do I get the variance from my calculator here?
I've been doing it the long way, so I write down the
That's fine.
standard deviation and then we square.
That's the only way.
Yeah.
That's the only way you do it. So I got 11.0806 squared, right? I think it's 0.7801. Now, variance is the only calculation that I did not do for you if you're doing this without the graphing calculator. But let me show you the variance formula real quick. For grouped data, the variance formula is S squared is equal to the sum of midpoint times frequency. Wait, let me make sure I got this right. Midpoint squared frequency minus the sum of midpoint frequency squared divided by n divided by n minus 1. So we have most of these pieces already. We have already got the sum of midpoint frequency right here. We did that already. The one we don't have is right here, the sum of midpoint squared frequency. We used the sum of midpoint frequency when we did the mean, didn't we? So we know that one. This one we don't know. So we would have to come up here and say midpoint frequency, another column, and we would have to say 44.5 squared times 10, right? That's how we would do it. So, and I'm going to just give you these numbers in case you're running this without the calculator so you can check your math, okay? Boy, I can't tell what I wrote there. Oh, there's a 4. 41,583.5. And this is 54,083.25. And this is 27751.25. 14280.5, and when I add them all together, I get the sum of midpoint squared frequency, which is what I need, and that is 157501. The sum of midpoint squared frequency. Okay? This is the sum of midpoint frequency. Those are the two numbers I needed. So I come down here in my formula, and I go, the variance is equal to the sum of midpoint squared frequency, the 157501, minus the sum of midpoint frequency, which is, 2588, and then I have to square that, divided by n, which was 44. Because it's a sample, I take this whole thing and divide it by n minus 1, which is 43. If it had been population data, they would have both been 44, and that is the only difference in the formulas, okay? And that would give me, guys, when you do that calculation, it comes up to be 122.7801, the same as the standard deviation squared. If it's different, it's going to be slight. Be okay, all right? Okay? The calculators save you a lot of math. Just have to make sure you're entering things correctly, you know what you're doing, okay? Now, let's talk about some frequencies, okay? We're talking about frequencies of class data. I've asked you a question down here. What's the relative frequency of class 1? Go back to class 1 and tell me, what would you say is the relative frequency of that class? How would you get it?
So we take the frequency of that class, which is 10, and we would divide it by 44.
Exactly. Same way we did it with ungrouped, right? So we're going to say for this one, relative frequency is going to be 10 divided by the 44, and I'm coming up with a decimal. Do I need to change it to a percentage?
No.
No. If I'd asked you the percentage of the class, you would have multiplied it by the percent, right? What about, let's talk about cumulative frequency a minute. What's the cumulative frequency of class 3? Huh.
So it's class, the frequency of class 3, class 2, and class 1.
Exactly. Cumulative frequency takes the class we're interested in, the class we've been asked about, and adds the classes that come before it, right? Cumulative. It accumulates all the way down through class 3. So that frequency is 10 plus 14 plus 13, isn't it? And that is 37. Now look, it asked cumulative frequency. It did not ask cumulative relative frequency, did it? If I had asked cum relative frequency, which I did in the next one, right? What would you have done? Divide it by what number?
44.
The total number. That's all you ever divide by, right? So we would have said 37 divided by 44. Okay, so with that in mind, can you tell me the cumulative relative frequency of class 5? With doing no math, people, you don't need to do math on this one. 1, thank you. The cumulative relative frequency says I'm going to add all of them up. Well, class 5 is the last class. When I add all these up, it's going to be 44. I'm going to divide by 44. I'm going to get 1, right? The cumulative relative frequency of the last class is always 1. Always. The cumulative relative frequency of the first class is always just whatever the first class is divided, okay? Those are the two where you don't have to add anything up. You understand? The first one, because it's just going to be cumulative relative frequency of whatever this is, 10 divided by 44, right? The only ones we have to sum are going to be if it asks us anything in the middle. And the last one we don't have to sum because we know it includes everything. Okay, maybe that'll help clear up some of those questions, okay? All right. I've got some data here, and I asked you if you could create a box and whisker plot for this data. Now, technically, this is not a test question. Okay, let's pretend this is a test question, okay? Because this is, if you don't understand this, you won't be able to answer the test questions. Do you know a box and whisker plot has a box, right, with lines in it, and it has a number line underneath it. It has the data. I've already arranged this data in ascending order, so I saved you that, right? And it has quartiles on it, doesn't it? So what's the first step in creating a box and whisker plot? Find the quartiles, right? So what I'm really asking you to do is, do you know how to find quartile 1, 2, and 3 of this data? Can you do that real quick?
Yeah.
Find the quartiles for this data. And then find the interquartile range just because, okay? Done? Okay. I happen to love this class. This class. And I'm not sure it's because you're following a class that does not even talk to me at all, or if it just, your guys are really good. But I like this class. Don't tell those other people that, okay? I hope they're not lost totally. And I like the fact that I'm not being recorded today, so I can say whatever I want to. All right, quartiles. If I want to find quartiles, which one do I start with? Yeah, it's a good idea to start with quartile 2, because it is the median, isn't it? So how do I find the median? Well, there's 10 of these, and I go to find the middle, 1, 2, 3, 4, 5, and I say, okay, these two are in the middle. The median is right between, right? Quartile 2, I would say it's 35 plus 35 divided by 2, which is going to be 35, right? That was easy. Now let's do quartile 1. And we're going to take the first half of this data set. There are 5 items, aren't there? And we're going to find the middle one. Well, that's easy. which one is it? And then let's do quartile 3. Whoops. We take this half of the data set and we find the middle one. Okay, and then I asked you to find the interquartile range. What did you do for that? 36 minus 22. It's the quartile 3 minus quartile 1 gives you the interquartile range. It gives you 50% of the data is inside that interquartile range. What did you get? 14? Right? Okay, so that's a range of 14. Now, let's talk about box and whisker. Box and whisker plot uses these three numbers, 35, 22, and 36, okay? It also uses the number line. Our data starts at 16 and ends at 41, so we're going to draw a number line. And we're going to sort of space it out. Oh, it's really hard to space it out, except for that I know that quartile 2 is 35, so it's kind of going to be in the middle of it, right in here somewhere. I need to start at 16. Let me just start at 15, and then I'll go 16, and then maybe 17. I don't know. Maybe I'm doing it good. You could do it in twos if you wanted to. Because I'm going to run out of room, right? Maybe not. Yeah, I'm going to run out of room. I'm running out. So I'm going to have to start this thing over, guys. I'm sorry. And see if I can be smarter and put the middle of it in the middle, more in the middle. Go down just by twos. I'm making this thing too big. Sorry. 37, 39, 41, 43. I'll just put 45, kind of skewed over to the side, but that's one we'll use, okay? That'll help. Okay, so now I'm going to put my quartiles in. My quartile 2 is right above 35, right here, and quartile 1 is at 22, isn't it? Right in here. And then I'm going to say quartile 3 is 36. Well, this is kind of weirdly shaped box, but that's it. There's my box for my box and whiskers, okay? You good with that? Now what about the whiskers? Well, there's a little bit more complicated formula than we're doing here to figure out, and it uses the interquartile range and the smallest item in the data set, but for our whiskers, we're just going to say, okay, to the limits of the data set, 16, and the highest one was 41 for these purposes, okay? So what I'm trying to get you to see in this thing is, what does a box and whiskers plot show you? Well, it shows you that this data set is skewed, right? It's one of the reasons I had trouble drawing it, is it says it's so far skewed. So it shows us what we call the skewness of a data set. It shows us the range of a data set, right? Can't you see the range from this? I mean, it's sort of telling you. It shows you where it shows you the concentration of data. I would say it shows me the concentration, like the middle 50%. 50% of my data falls right in here, the interquartile range, right? It's between quartile 1 and quartile 3. 50% of my data is between these two numbers. It shows me the spread of my data. How spread out is this data? If there was an outlier, it would show up like over here, way over here somewhere. It would show up as a little dot. So it would show me outliers of your data. What does it not show us? Well, let's talk about this. Does it show you the mean of the data?
No.
No. Does it show you the mode of the data?
You can kind of
Mode?
guess,
Which, well, does it, no, it doesn't show me which one of these had multiples, does it? That's the mode. Does it show me the median of the data? Yeah, that's quartile 2. That's the only thing it's really of that mean, median, and mode. The only one it's going to show me is the median of it, right? Now, there's a way to do this, and I put it in your notes for you. There's a way to do it with calculator that's kind of cool. So if you're doing this, let's see if I can do it for you real quick. You would just go in and edit a list. Let's just make it list 1 again. And put the data in there. So I got 16, 19, 22, 22, 35, 35. There's 3 35s, right? And 36, and 40, and 41. Did I do that right? I got 10 items. They look pretty good, okay? Can you see it? Okay, so now if I want to do a box and whisker plot, first I've got to turn on stat plot. So I have to, my stat plot right up here, I have to say second stat plot, and I've got to make sure it's turned on. That's the one I want, is the box and whisker. So I'm just going to click on it. It's already on because I used it. And then the plot I want, I don't know if you can tell, I've already got it highlighted here. It's the box and the whiskers, and it has little dots on each side of it. Because if there were outliers in the data set, it would put little dots for us. Otherwise, you'd be using this one, which, let's blow this thing up for you. Okay, now you can see better, right? See the little dot? And if you'd used this one, it would not put the outliers in the data set. So I chose that one, and then I've got to tell it which list I'm using. Did I put it in list 1 this time? Okay. And then I'm going to go there. We're good. Now, to see the plot, I go to Zoom. I say Zoom, and then I go down to Zoom Stat, which is number 9 for me. And there's the box and whisker plot. No numbers at all, right? And the only way to get numbers is you see this trace button here. You say trace, and you see it starts at the median, and it tells me that the median is 35. But if I arrow over here, it'll tell me that quartile 1 is 22, and that the minimum is 16. I'm going to arrow back over here to quartile 3 was 36, and the maximum was 41. So I can find out what they all are if I get it into a plot, and it's kind of cool, and I don't know, it's kind of fun to learn something else that your calculator will do for you, okay? Please understand this. If you don't learn to plot it, you should know what it does for you. It tells you, and what it does not do for you, you know? Know that it doesn't give me the mean, it doesn't give me the mode, but it does tell me the range, and it tells me the skewness of the data. And what we really use box and whisker for, more than anything else, is outliers. Like I said, if there had been a data item up here where, you know, it was like 85, right? Way away from all the others. How would I know that it was a true outlier in my data set? You can't just look at your data set and say, well, that one must be because it's so much bigger than the others. You have to have a mathematical reason. And the box and whisker says 1.5 times 1.5 times interquartile range past the highest item. Okay, so it gives you that calculation, okay, that you could do. If you put it into one of these things, it'll show it to you as an outlier. It'll say this one's way past my calculations for these whiskers. If it's way past the calculation for the whisker and the data isn't inside there, it's an outlier. And that's how we actually can identify true outliers in a data set. Are you any questions? Because I've covered all of what I think I need you to know. Now, let's go back because you got a test coming, right? Let's go back to what I think is important. I want to go to the bottom, to the back of Module 2 and take a look at your test review, because these review questions, they say chapters 1 through 3, and you can change that. These are 1 through 2, okay? I don't know what page I'm on. I'm just past worksheet for chapter 2, okay? So, I would definitely go through here and work this one. Now, I do have a video of the worked solutions to this. I think I posted it inside Module 1. I think there is a video review for this that works through this review. And I'll post the one that we just did as soon as I have a chance to record it. But this does take you through a lot of problems and a lot of questions. In other words, it's going to take you through a lot of questions that are going to help with vocabulary. I didn't go over any vocabulary really today, but this will take you through most of it, okay? What else can you do to study for vocabulary? Same thing I told you before. You see these words that are in bold print? Well, let's get back to where we had a lot of them. Okay. Do you see these basic terms and all of that in Chapter 2? Sorry, in Chapter 1, page 2? And once you start and you see all these definitions, you should know all of those definitions by now. You should know all the things that are on your formula sheet. You should know all of the symbols that are on your formula sheets for Chapters 1 and 2. And that gives you what you need to study for. We need a green Scantron. Did I already tell you this? I'm repeating myself. I have another class. You need a green Scantron, if you do not have that, don't not come to class, because I will have a few extras. I just won't have enough for everybody, so please, some of you get green Scantrons. You need a pencil for that green Scantron, and you need your calculator, not somebody's that you borrowed at the last minute and you don't know how to use. Okay, I've had that question asked before when some students came to class. They said, can you show me how to use this? I just borrowed it from my cousin, and I cannot. Now, if you forget your calculator or the batteries go dead, then all I have to offer you is a simple scientific, and I'll have some extras of those, one of these, right? But one of these is not going to do everything that we just did. That's all I have. But you can use one of those if something happens to yours, okay? Okay? So you want to make sure you have fresh batteries, you have it charged, whatever it takes. I don't have any graphing calculators to loan out. I think that's it, guys. I have everything else for you. I'll see you Monday? No, Wednesday, right?
Yeah.
All right. See you Wednesday.
Yeah.
You're welcome.